Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with 4.4, which is prove triangles congruent by side angle side and hypotenuse leg is what those stand for. So we're doing more proofs today, a couple more different types of congruence postulates. And so we had side, side, side for 4.3, and now we have side angle side and hypotenuse leg. Our central question is, how do we use sides and angles to prove triangles are congruent? All right, we have a warm-up here. It says solve for x using the triangle sum theorem. If you recall, how many degrees does a triangle add up to? It adds to 180 degrees, okay? So why don't you guys go ahead and see if you can solve this for me. All right, so we have this triangle here. It's going to add up to 180, so we're going to add up all the angles. 2x plus 3x plus 55 equals 180 degrees. All right, how many, anything to distribute? No. Any like terms to combine? Yes, we got 2x and 3x is going to be 5x plus 55 equals 180. Solve for x by subtracting 55. We have 5x equals, what's 180 minus 55? That's going to be 125. Divide by 5. We get x equals 25 degrees. And there's our answer. All right, sounds good. So this format's going to be kind of important for these examples. So, so example 1, we have solving for missing angles. In triangle ABC, measure of angle A equals measure of angle B plus 30, and measure of angle C equals measure of angle B plus 60. Find the measure of each angle. It says, hint, draw a triangle and call the angle that they are using to describe other angles X. All right, so I'm going to draw a triangle here. I like to draw the same triangle every time, so I'm going to go like this. That's really bad. Let me try to do that a little better. It's not perfect because it won't let me draw straight lines, but this will work. Okay, which angle are they used in describing other angles? Well, you can see that we're calling measure of angle A is measure of angle B plus 30, and so is measure of angle C is measure of angle B plus 60, right? So I'm going to call B, I'm going to call that X, okay? And we have A, B, and we have C, right? So if B is equal to X, what is angle A going to be? Well, it's measure of angle B plus 30, but angle B is X, right? So it's going to be X plus what? X plus 30. And measure of angle C is measure of angle B, which is X plus 60, so it's going to be X plus 60. Okay, and now we can solve for X by using the triangle sum theorem, right? Which means that all the angles add up to what? They add up to 180. So we're going to do x plus 30 plus x plus 60 equals 180. All right, let's combine like terms now. We got x, and x. We have 30 and 60. We have 3x plus what, 90 equals 180. Subtract 90. We get 3x equals 90. Divided by 3. Get x equals what, 30? So measure of angle B is 30. How do we find measure of angle A and angle C? Well, measure of angle A equals, it's going to be measure of angle B plus 30, so it's going to be 30 plus 30, which equals 60 degrees. And we can do measure of angle C, measure of angle C equals 30 plus 60, which equals what? That equals 90 degrees. So we have measure of angle A equals 60 degrees. Measure of angle B, which was X, equals 30 degrees. And measure of angle C equals 90 degrees. And there is, we solve for these angles by, solving for X, okay? So the trick for these problems is making sure that you label the one that they're using to describe other angles. You just call that X, and then you do whatever it's saying to do to X, basically. And that's kind of how you solve this. Okay, we have another example down here which is very similar. Right down here, this is 2 times measure of angle B. Okay, so why don't you guys go ahead and try checkpoint 1. I'll zoom out a little bit so you can see what we did, and try checkpoint 1, see how you do. Okay, let's go through it here. So we have to draw a triangle again. I like to draw the same triangle. It's kind of like my method here. So do the same triangle. So we're calling measure of angle B, we're going to call that x, okay? So we'll call B over here, we'll call this x. We have A and we have C. So A is 2 times measure of angle B. Well, measure of angle B is x, so it's going to be 2x. And C is going to be 3x. So we do the same thing as we did before. We're going to do x plus 2x plus 3x equals 180. Combine like terms, it's going to be 6x equals 180. Divided by 6. X equals what? That's going to be 30. And that was measure of angle B. We got to find measure of angle A now. Measure of angle A equals 2 times 30, which equals 60. And measure of angle C equals 3 times 30, which equals 90. So we got the same problem, same numbers as before, but with different kind of solutions here. So measure of angle A equals 60 degrees. Measure of angle B equals 30 degrees. And measure of angle C equals 90 degrees. All right, hopefully that makes sense. It always helps to draw a picture if you're able to, or draw a diagram. All right, let's get into some other examples now. So, or some definitions. So, we have definitions. The leg of a right triangle. In a right triangle, a side that is adjacent. What does adjacent mean? It means next to, right? Adjacent, or next to, the right angle. So, for example, if we have a right triangle like this, here's a right triangle. A and B are legs. So A and B are legs. And C would be the, what's C called? C is called the hypotenuse, and that's the side opposite the right angle. That's why I drew that arrow there. It's always the side that's opposite the right angle. So this would be C. Okay? All right, so let's talk about side, angle, side now. So we talked about side, 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 where all 3 sides are congruent. This one, you could also prove triangles are congruent if you have side, angle, side. So if you have 2 sides, like for example, these 2 sides here, right? And then these sides, and then also the angle between them is also congruent, okay? The angle has to be between them. So if you go around the triangle, right, the angle has to be in the middle here. The angle has to be right in the middle. And the same thing here, the angle's right in the middle between the 2 congruent sides. Okay, so RS is congruent to what? It's going to be UV. Angle R is congruent to angle U. What else do we have? RT is congruent to UW. And triangle RST is congruent to what one? So RST would be UVW. Okay? So that's a side, angle, side. So if you're proving using side, angle, side, you need 2 congruent sides and the angle that's between them that's going to be congruent. Okay? That's what we kind of talked about down here. All right, let's keep going here. So we got a couple of proofs to do. Hopefully this will be more, will make more sense the more we go through these. Okay, so again, we have, what's the 2 sides of the columns here? 2-column proof. We have the statement and the reason. Okay, so we do this, we do this, and we go like this. Okay? All right, so it's this rate of proof. We know AB is congruent to DB, and ray BC bisects angle ABD. We're proving that triangle ABC is congruent to triangle DBC. Okay, well, what do we always start with? First thing we always start with is our givens. We're going to do AB is congruent to DB. Oops, that's 1. And then the other one was ray BC bisects angle ABD. And the reason for that is these are givens. Okay, what comes next in our proof structure? In our proof structure, usually what comes next is definitions. So is there like midpoint or bisector, anything in here that we can use to like figure out more information? Well, yeah, we have bisects. So BC bisects angle ABD. What does that mean? This ray right here bisects this big angle ABD. So what does that mean about an angle bisector? What does it do? Well, it splits the angle into 2 congruent parts. So these 2 angles are going to be congruent here. Do you see that? Does that make sense? So we can say that, we'll call that angle 1 and angle 2. We're going to say angle 1, we will say, well, let's do it the other way. We're going to actually call that, I'll erase this here. So we're going to say that angle ABC, better to get in the habit of doing this, is congruent to what other angle? If we go ABC and to go the same direction with the other triangle, we'd have to do DBC, right? And what's the reason for that? That's definition of angle bisector. Okay, the definition of angle bisector says that those are going to be congruent. Okay? All right, now, third thing after definitions is either a shared side or congruent angles. Or vertical angles, I mean. Now, do we have a shared side or any vertical angles here? Well, yeah, we have the shared side in the middle here. Let me zoom in a little bit. Can you see that shared side? Those slashes are kind of sloppy. What is happening? So we can see the shared side in the middle here. These are going to be congruent, right? So we can say that BC, the shared side, is congruent to BC. And why is that? What's the shared side property called? It's called reflexive. Okay. All right. Step 4. Now what do we have here? Let's see what we have. We have a side. We have an angle between, and then we have a second side in the middle here. So what's the reason we can say these triangles are congruent? We can say side, angle, side, because we have two sides and the angle between them which are congruent. So ABC is congruent to DBC, and the reason for that is side, angle, side. Okay, I'm going to leave it zoomed out here. Why don't you guys go ahead and try checkpoint 2. Just be aware, I'm going to give you a hint here that there's going to be vertical angles for this problem here. There's going to be vertical angles, okay? So why don't you guys go ahead and give this one a try, see how you do. Okay, so again, checkpoint 2, we need a statement. We need a reason. We do this and this. All right, so step 1, what do we have here? It says JN is congruent to LN, KN is congruent to MN, those are our givens. We're trying to prove that JKN is congruent to triangle LMN. So we start with our givens. We have JN is congruent to LN, and KN is congruent to MN. The reason for that is given. Okay, so we know these are congruent, these are congruent, and these are congruent. Okay. So are there any definitions in the givens here? Anything like midpoint or angle bisector? There is not. What comes after definitions? We either have reflexive or vertical angles. Are there any shared sides here, reflexive sides? There are not. Are there any vertical angles? There are. These angles are congruent because they are verticals. We can say that angle 1 is congruent to angle 2, and why can we say that? That's because these are vertical angles. Okay? That is why they are congruent. All right, now what do we have here? It looks like we have a side. If we go around the triangle, we have side, angle, side, and side, angle, side. So we can say these triangles are congruent now. JKN is congruent to triangle LMN, and the reason for that is side, angle, side. All right, 3 steps. Sounds good. Okay, we have one more type of postulate here, or theorem. This one's a theorem, actually. It is called hypotenuse leg. This one's a little tricky, okay? So hypotenuse leg, the triangles are congruent if we have the hypotenuse these are congruent, and also one of the legs. So either this leg or this leg down here. If we have a hypotenuse and a leg of a right triangle, this is I'm going to write only right triangles up here, so you know that. Only right triangles, okay? It's only for right triangles. If that's the case, if you have a hypotenuse is congruent and one of the legs is congruent, then the triangles will be congruent, okay? All right, let's do this problem here. So, we need our statements. We need our reasons. All right, so. Okay, what do you think here? So what do we start with? Start with our givens. We have AB is congruent to DB. And we also have angle ACB and angle DCB are 90 degrees. The reason for that is givens. Let's mark on here what we know. So we know these are congruent. We also know these are right angles right here. Okay? All right. Well, let's keep going here. So step 2. Are there any definitions in the thing here? Well, 90 degrees means they're complement. Well, complementary is usually 90, but there's nothing we're going to do with that information there. So we have no definitions. Okay. Do we have any reflexive shared sides or vertical angles? We do. We have a shared side here, which is what? We have BC is congruent to BC, and the reason for that is it is reflexive. Okay? Now, what do we have here? Well, we have the hypotenuse. Both of these are congruent, and we also have a leg, which is congruent. So what can we say? Well, we can say the triangles are congruent. Triangle ABC is congruent to triangle DBC. And the reason for that is hypotenuse leg. And that is the proof. A lot of proofs recently. You guys have been troopers. Hopefully this makes sense. If it doesn't, make sure you go and watch it again. Come get help. Thank you for watching. Have a great day, and we will talk soon.